Hi everybody, so welcome back to our work on complex numbers, and today we're going to consider how to sketch some regions in the complex plane. So up until now we haven't done much sketching. We've thought about maybe sketching or just plotting a point Z in the complex plane and maybe thinking about the complex conjugate. But what if we want to plot something more than just a single point and we want to draw a region in the complex plane? So that's what this section of work is going to be about. So by considering a set of complex numbers that satisfy certain conditions, when we sketch that set, we get a corresponding region in the complex plane. So for example, let's have a look at this simple situation here where we've got Z such that the real part of Z is equal to 3. So that means that this is a set of complex numbers. What sort of numbers are in that set? Well, 3 plus 2i is in that set because it's a complex number that has real part equal to 3. So we don't care what the imaginary part is as long as the real part's equal to 3. 3 plus 5i is in that set because the real part of that complex number is equal to 3. 3 minus a half I is in the set, again because the real part's equal to 3. But 2 plus 3i is not in the set because the real part is not equal to 3. So this set contains all complex numbers whose real part is equal to 3. Okay, so if I have a look at this on the complex plane, then if the real part is equal to 3, all of the x coordinates are going to be sitting along either at that point there on the axis, or they're going to be vertically above and below that point, because that's the line where all of the complex numbers have real part equal to 3. It's a bit of a wonky line when I draw it like that, sorry. If I have a complex number out here, then this one's going to have maybe 4 point something is going to be the real part, and these complex numbers over here are going to have negative real part. So everything along that line and only along that line will be the complex numbers that have real part equal to 3. Their imaginary part can be anything you like. So for example, this point here looks like it's 3 plus I, and this point down here is 3 minus 2i. I don't care what the imaginary part is. All I'm worried about for this example is the real part being equal to 3. So if I were to sketch that region in the complex plane, it would just look like that vertical line. So the first step in sketching regions in the complex plane, step 1, is think about what sort of complex numbers are in the set. If you can't read the set, then you're not going to be able to draw the picture. So the first thing to do is think about the set that you're given before you start sketching the picture. Okay, so in this next example, we've got something that's a little bit similar, but instead of an equality, we've got an inequality. So that's going to make things a little bit trickier, but not too much trickier. You just have to think about it in a different way. So let's think about step 1, and I'm going to change the question slightly just to do step 1. So instead of looking at the imaginary part of Z is less than 2, I'm going to look at sketching the set of points where the imaginary part of Z is equal to 2. So let's see if we can do that first, and then we might be able to figure out how to do that one. Okay, so I'm going to just draw my axes over here. Sorry about the wonky axes. It's harder to draw on this than it is to draw on paper in the lecture theatre, actually. So here's my set of axes. Let's just imagine that they're both straight lines. And we saw something that looked like this in the previous example. In the previous example, we sketched the real part of z was equal to some number, let's call it c. So that was the set of points z such that z was equal to c plus I y. Okay, so we didn't care what the y was as long as the real part was equal to c. So we've got a similar situation here, except we're interested in what the imaginary part is instead of what the real part is. So this one says we want the set of points such that the imaginary part of z is equal to 2. So if I was to write down an arbitrary complex number that satisfied that equation, it would look like z equals x plus 2i. So x can be anything you like, provided that the imaginary part of z is equal to 2. So if I was going to come over here now and draw this on the Argand diagram, then I would go up here, so I'm about there, so the imaginary part of z is equal to 2, so that point there is actually z equals 2i. And then if I think about drawing a horizontal line this time, let's imagine that that's a horizontal line, then any point on that horizontal line would look like this one. The x coordinate could be anything you like. It could be positive or negative or even 0, but every point along that line would have imaginary part 2i. Okay, so that's the equation, imaginary part of z equals 2i. Of course, that's not what I was asked to do. I was asked to sketch the imaginary part of z is less than 2. So let's go back to the Argand plane and let's have a look at a point that's just up here above the line, imaginary part of z equals 2. So if you think about this complex number here, its imaginary part is going to be some number, looks like it might be about 4 there. The imaginary part of this complex number is going to be about 4i. If I've got a number up here, its imaginary part's going to be maybe 6i, and the same with numbers over here. It doesn't matter which side of the y-axis or the imaginary axis we're on. If I'm above that line, the imaginary part is going to be a number bigger than 2. This one might be about 3 if I had a complex number that was here. So it looks like if I'm a complex number above the line, then the imaginary part of that complex number is going to be bigger than 2. What happens if I'm below the line? Well, certainly 0 has got an imaginary part less than 2. What about a complex number there? Its imaginary part looks like it might be about 1. What if I've got a complex number that's down here? Its imaginary part looks like it might be about -5. This one might be about -2. So if you think about all the complex numbers that are below that line, imaginary part of z equals 2, then it looks like they'll all have imaginary part less than 2. And in fact, that's the case. If we're thinking about the imaginary part of z being less than 2, then all those numbers lie below that horizontal line that I've drawn. Okay, well, it's certainly true that the imaginary part of z less than 2 looks like that bit that I've just coloured in there, but the problem is on my sketch I've also got this horizontal line that I've got as a solid line. Now that's the line where the imaginary part of z equals 2. I don't want the numbers that have imaginary part of z equals 2, I want it to be less than. So the way we indicate that on our sketch is instead of having a horizontal, a solid line, and I might just rub it out now. Instead of having a solid line, we indicate it by a dotty line like that, a line that's got breaks in it. And what we mean by that is that's the boundary, but we're not including anything on the boundary. So we're thinking of the boundary here as being the imaginary part of z equals 2. So we don't want equals 2, so we'll put the dotted line in, but we want everything below that. So that gives me the imaginary part of z is less than 2. If the region I was trying to sketch was the imaginary part of z is less than or equal to 2, so I would have less than or equal to 2, then I would have drawn that as a solid line. Okay, so if it's a strict inequality, less than or greater than, we just use a dotted line to indicate the boundary that we're looking at and that we're not including the boundary. If it's got an equal sign as well, then we indicate that with a solid line. Okay, so that's the next example of sketching in the Argand plane.